In this video, we're going to derive the moment generating function for a binomial random variable. So let's say that our random variable is x and it is binomially distributed with parameters n and p like this. So remember, the moment generating function, which is written like this, is the expected value of e to the power of tx. And in this case, that means that it's going to be the sum over all of the sample space of the binomial distribution, which is when x is 0 up to n. These are the values that x can actually take of e to the tx times the probability mass function for the binomial distribution. And that is n choose x times p to the x times 1 minus p to the n minus x. What we now need to do is, of course, see if we can simplify this and make it so that we don't have to write it as this sum. Can we maybe write it in a nicer form, a closed form? Well, it turns out we absolutely can. All we got to do is slightly rearrange this. So we're still going from x equals 0 up to n, but e to the tx, what I'm going to do is I'm going to rewrite it as e to the t and then to the x. So I can write this as n choose x, and then again, e to the tx and p to the x, I can rewrite this as e to the t times p all to the power of x, and then 1 minus p to the power of n minus x. Hopefully that makes sense. That still gives me the e to the tx and the p to the x. The reason I've done this, though, is that now this is in the exact right form to actually write it, because this is in a binomial form. So what I mean by that is, if we consider just in general a plus b to the power of n, using the binomial theorem, this is equal to the sum from, let's say, r equals 0 up to n of n choose r times a to the r times b to the n minus r. Okay, so and just comparing that to what we've got, you can see that it actually looks exactly the same. We're using x instead of r, but that's just an index. It doesn't actually matter. And we've got a as e to the t times p, and we've got b as 1 minus p, which means that I can rewrite this thing up here as simply e to the t times p, because that's kind of like a, plus 1 minus p, because that's kind of like b. And that's all to the power of n. And this is the moment generating function for a binomial random variable. Typically, it's a bit nicer to write it as 1 minus p plus p e to the t. So just moving the terms around a little bit there. But this is how I would write my final answer. So this is the moment generating function for a binomially distributed random variable with parameters n and p. Thank you so much for watching, and I'll see you in the next one. Cheers.